So for that, we're gonna do univariate data drift detection on all the features. And then we're also just gonna quickly display all the features and see how the potential drift has happened. And first of all, we can see here that in this period, we get some alerts as well, but there is actually no real impact on performance. And I can already see why that's the case, because it also happens with the drop-off location. And that is probably actually, if you see, this is quite similar to here. And that is probably the weekend. And we can see here that there are some trends in this data, that there are some weekdays, presumably. And the whole idea is because this is a very small data set, how this distribution looks like, it's probably something that's gonna get flagged by univariate drift alert, because it's just on a feature level and it's a imperfect test. And that's why it's so nice that if we have this algorithm, because this algorithm does capture more complex things and also takes the impact on performance into account, because this data drift did not impact performance. And the reason being is because it's a weekend and we have observed a weekend in the past. So we actually know how to deal with this. And that's why we're only going to focus on this area and only try and explain this area, because here our machine learning models actually knew how to deal with it and actually worked perfectly well. And then we can see here, maybe the first thing is that the pickup location has drifted here in these parts. And then also we can see here that the drop-off location also gave some alerts during this period, which is fairly interesting. If you look at the trip distance, that hasn't really changed that much. Also, the vendor ID stays fairly constant. Same for the fare amount. The pickup time has changed as well. And I think this might actually be the feature to look into a little bit more, because we can see here, specifically, we're here in these 3 days around December 23rd, 24th, and 25th, that our model is not performing that well. And we can actually also see that here significant drop in the time people get picked up. And this is, of course, very interesting because December 24th is the holidays and it's Christmas. And typically in the US, I think this is actually also a Friday in 2016. So this is not a weekend day. These 2 days are, but they are holidays. And in our training data, the week prior, we didn't see any holidays. So the whole idea is that then this data is new. The patterns that are observed here are different. Maybe it's different type of customers that want to go to different locations indeed, that also get dropped off somewhere else and that have different tipping behavior as well. And that is exactly what we're picking up on here. And it's considered data drift because in our model, the whole concept of a holiday doesn't exist. So this might be considered a little bit of concept drift. Now, a holiday might be similar to a weekend. So that is why we are still able to pick up some of the changes there, and our model can deal with it in some way, but not fully. And that is, of course, what we then as data scientists try to do, is that we try to use this univariate data drift detection to piece together what actually happened here during this period, and then we can come up with a way to find actual resolutions.